Welcome to qnawire.
AB that's rotating at with an angular velocity of 60 radians per second. We need to determine the velocity of slider C at the instance when theta is 60 degrees and phi goes to 45 degrees. And then after that, we need to sketch the position of bar BC when theta goes to 30 degrees, 60 degrees, and 90 degrees to show the general plane motion. Okay, so we are given that omega AB is 60k radians per second. And then we need to find the velocity of point B. Okay, this is just omega AB cross the position vector from A to B. Okay, and then this is 60k cross 0.3 minus sine 60 degrees I plus cosine 60 degrees J. Okay, so we are using this coordinate system. Usually this is the coordinate system you'll be using unless otherwise stated. So yeah, so theta is 60 degrees, so the I component is minus sine 60 and the y component is cosine 60 degrees. Okay, and then if you simplify, this is what you get, 9 minus I minus root 3 j meters per second. Okay, so what happens is that this is square root 3 over 2, and then this is half. Okay, so yeah. Okay, then k cross I gives j, and then with a minus sign, so minus j, and then k cross j is minus I, so this is what we get. Okay, then the next thing is we use the relative velocity equation. So vc equals to vb plus omega vc cross the position vector of c relative to b. Okay, so and then from this situation, you can tell that vc is going to be pointing downward. Okay, so because when AB is rotating counterclockwise, BC is going to move counterclockwise as well, and then C will be moving downward along the channel. Okay, so VC will be written as minus VC in the J direction. VB is 9 minus I minus root 3J, and then omega BC, will just set it as positive cross the position vector of C relative to B, this is 0.6, minus cosine 45 degrees I minus sine 45 degrees J. Okay, then this is 9 minus I minus root 3 J plus 0.6. Okay, so this is square root 2 over 2, square root 2 over 2. Okay, so this is what I'm going to do. 0.3 because 0.6 times half times root 2 times omega bc. And then when you do the cross product, you get k cross minus I, that is minus j, and then k cross minus j gives you I. Okay, so I minus j. Then when you combine the terms, you have minus 9 plus 0.3 root 2 in the I direction plus minus 9 root 3 minus 0.3 root 2 omega bc j. Okay, so there's the omega bc here. Okay, now we are able to compare the components. Okay, so the x component we have 0.3 root 2 omega BC equals to 9. This gives omega BC equals to 21.2 radians per second. Okay, and this is counterclockwise. Okay, then for the y component, okay, so you have minus VC at the left hand side, you have minus 9 root 3 minus 0.3 root 2 omega BC at the right hand side. So I can just write VC is equal to 9 root 3 plus 0.3 root 2 omega BC. So omega BC is you substitute from the previous step, and then this you get 24.6 meters per second. Okay, so in vector form, VC is minus 24.6 J meters per second. Okay. Okay, now we sketch the general plane motion. So this is how the general plane motion looks like. Okay, so this is point A, and then B is here, and C is here. Okay, and then yeah, so this is how the rods AB and BC move when theta is 30 degrees, 60 degrees, and 90 degrees. Okay, and that's all for this question.